Cross-site request forgery. What is it? This is an attack where the hacker is able to trick the user into running a request against a web application that they have access to and that they have already logged into and are authorized to use. They do this by embedding code inside of the attacker's mechanism, whether it's a phishing attack or some sort of a site. And as a result, the victim ends up sending out the request and executing the attack. So the request is actually sent by the victim, not the attacker. And because of this, it can be very difficult to detect. Some people call this the one-click vulnerability. The OWASP threat assessment for cross-site request forgery, number 8 on the list, is that this is an application-specific attack where the application is vulnerable by virtue of not checking that the state information, the credentials of the user are not being re-authenticated and confirmed that they're coming from the actual site. The exploitability of this is average because it can happen through cross-site scripting, through image tags or cross-site scripting, and because the user is already authenticated, the attack succeeds. The weakness on this is that it is fairly common. The browsers store these credentials, and attackers can create these malicious pages by virtue of using things like F12 on Internet Explorer or the Fiddler or other tools to be able to see how a valid request would be processed, and then they embed that into their actual page. The impact on this is moderate, which means that the data can be changed without the user's knowledge, and because of that, it can have some serious consequences. For example, suppose a user has a direct deposit. They want to be able to send their paychecks into a particular account. They might go ahead and log in, and a lot of times it's easy just to remember me and remain logged in. That way we don't have to type in our password every single time we come to the page. What happens is that our identity is then cached inside the browser, and then when we make requests on the page, it uses that cached credentials to be able to pass it in with the request. The attacker depends on this authenticated session to succeed. So what they do is they identify whatever the request is that moves funds around. So for example, the application might have a transfer fund function that takes an amount and then a destination account and then processes it. So the attacker goes out and creates some sort of a phishing attack, whether it's embedding onto a submit button or into an image source, adds a tag. In this example, you can see that the image source, rather than being an actual picture, is the actual HTTP URL request that does that transfer of funds. And by having a width of 0 and height of 0, you don't see that this image doesn't exist. It just goes ahead and runs that request as part of the loading of the page. So the phishing email gets sent out to a user, whether it's coming from the post office or somewhere else. This was one that I saw not too long ago where I got from the U.S. Postal Service saying, hey, you have a box at the post office, just click on this link to go out and deliver it. It might even be something that is simple like, send me a picture, where I've got the actual link sitting here, and it could be just a regular page that gets loaded. And so by going out and doing this and then taking a look at the code, you can see that this image picture, the best security team ever, actually has a tag attached to it that is an image that height is 0, and it goes out and does that actual transfer of funds. And if you don't think that that's scary, just think about what can happen in your code. The cross-site request forgery depends on the authenticated user that has valid state, and the site with malicious intent has code on it which sends that request in. And because it's already authenticated, it executes against our page because our site is not confirming that that request is coming from the new session ID, which is updated for that page. Let's take a look at what this looks like in action. For our first example, we'll take a look at how WebForms does the CSRF attack. In this case, we have an ASPX page, typical web form where the customer goes ahead and logs in. Login is jim@contoso.com with the secret password. If I can remember it. I click on the Remember Me, and then click on the login, and it takes us in, and we can then go out and we can see here's where our account is. I might be able to go out and say, okay, well, I want to update my account and send my stuff to a different account. And if I click on update, it would then go ahead and update that. Now, what a hacker would do is go out and they would use the F12 or maybe the fiddler to be able to watch the requests that go through on the network. And with this information, we'll go ahead and turn on capture. When we update the account, we can see that this goes out and sends a post request to the site to update our account to be all ones. If I look at this request and double click on it and I take a look at the request body, I can see how this got sent. We've had some view state information that gets sent, as well as a couple of parameters telling us which account we're going to, and then the function to actually run. And a hacker can see this by virtue of using just standard web tools. So the key is that the web state, the view state generator, has valid update information on that. What the hacker does is goes out and uses that information to be able to tell what's going on. Now, suppose we have an email where we've got this remembrance pictures. We can click on that link and it goes out and says, oh, guess what? Here is the best security team in the world, and I can see, there's the picture of all the guys and the people that we've been working with. And the thing is that this is just looks like a regular image page. But if I right click and I say view source, what I'll find is that the hacker actually has the image, but also has a hidden form on this page. Notice it's called hidden form. And in here is a bunch of inputs that are all hidden, and then a script that goes through to bounce through and actually perform the exploit. And what happens is that by virtue of just opening this page, if I go out and I refresh this page and I click on log out and log back in, then you can see that the account has been hacked to take over to the hacker's account, the 987654321 account number. Now, in web forms, the way that we can stop this is by taking advantage of the idea that when the view state is generated for a page, we inject a little bit of entropy to make sure that data is unique and random. So if I go into Visual Studio, you'll see that here's my default page. All I have to do is go to the main page here, and then I can add in the page init a method to go out and add some view state user key. Here I would say view state set that is equal to my session, and then I'll use the session ID. And what this will do is it will inject some entropy so that the view state is actually going to be a unique number every time that the application runs. And so this will effectively shut off the cross-site request forgery attack inside of a web forms app. Now, inside of an MVC app, we don't use that view state. We don't have all that block of data. So the way that it maintains the identity is either by putting it onto a cookie or somewhere else. So I have another application that I wrote, and I'm just going to go out and I'll show you what it looks like. In here, I've got my application, and this is an exploitable application at this point. But here I've got my banking account. If I click on bank, it'll go out, it'll open up. I have to log in order to get to that page. So we'll log in, jim@contoso.com with a secret password. We'll click on remember me, click on login. And then from the banking page, you can see that here's my accounts. I've got my 401k, I've got Jim's retirement account, I've got the savings. And if I take a look at the details on any one of these, it kind of shows me, here's the transactions that are going on. I've got my balance. If I go back, I can see my savings and all the details of each one of these different kinds of accounts. Again, I go out and I take a look at the page that has the cross-site request forgery attack on here. In this case, this one is running from a link where I can go out and say, check out this picture. And maybe I got this on an email. If I click this link, it's going to go out and it brings up this page where, again, I've got my best security team ever. Except this time, when this thing ran, if I go out and I say, okay, do the old F12 on this page, I can turn on capture. I can click on the DOM Explorer. In here I can see that here's my form, and inside of there is some hidden data, but I've got the request is actually coming in here as an image this time, and I've got just a simple local host running the transfer with the amount. And if I were to take a look at the network and then reload the page, every time this page goes, it goes out and does a quick transfer of the details of that page. So if I come back here and refresh, you'll see that Jim's retirement account just went to 0. So how did that thing work? Again, this is looking at it from the MVC kind of an application. In an MVC application, we still have the ability to stop this, and we do that with anti-forgery tokens. So in MVC, what I'll do is I'll go into the page for this, and we'll go ahead and stop this. And I'll go out to my bank controller, and here's my transfer method that goes out and does the transfer. I've got this validate anti-forgery token, which has to be on the details page. So in my details CSHTML, where I come down and I've got my markup for where the actual app transfer takes place, if I click on this and I uncomment this, and I require that forgery token to be on the transfer when I'm on the page, and then I also, in the bank controller, is validate that a anti-forgery token exists on that page. Now this will then go ahead and require that we have something set up for this. So that then is going to confirm that the request came from this page and not from some other third-party source. So let's go ahead and run this. And then go out to our request page, click on the bank, and let's just go ahead and edit this account. We'll put some more money back in here. Save it. And then we'll open up our attack page, which is the exploit. And again, we're just going to reload this page. So I'm going to click on refresh. And in this case, what you'll see is that the request ran, but it got a 500, and that's because in the response to it, it required that anti-forgery token. And so we effectively were able to stop the exploit from taking place. If I close that out, take a look here, and I refresh this page again, now the account is back to where it was, and we don't have that exploit taking place anymore. The way we prevent the cross-site request forgery attack from happening is we include something unique in the client that the server can validate when the request is received. On web forms, we use the view state user key like we showed you. It must be a unique value for each user, and so it's recommended that you use the session ID for that. On MVC, we can use the anti-forgery tokens, in which case then in both the controller and on the view, we add that extra piece of information. Then we require the user to have that confirmation with a shared secret. So we confirm it in our code. The potential risk of this request forgery is that it exposes victims' private information to the attacker. So the potential risks of this is that it exposes the victim's private information to the attacker. The attacker can alter the information, can retrieve account data, can make purchases, can drain an account, and the victim is usually unaware that any changes have taken place unless they go back and refresh and look at their account and the data that should be there. So this is a very common attack. It often occurs through some sort of a phishing attack combined with the security flaw. An example of this happened at FTD a number of years ago, where customer data was accessed by copying a cookie from one computer to another. In addition, sequential values, if you're using predictable values for account numbers and things like that, makes it easier to guess which numbers are valid for that attack.